Okay, so YouTube, today I wanted to post a tutorial on how to use Python and various packages associated with Python like pandas to analyze personal financial data or like credit card transactions. So the context here is you have a bank statement, in this case I'm going to be using a credit card statement, which typically you can download from your bank webpage as a CSV file. And when you open that in Excel, you'll see you'll have the date for all your purchases, a description of that purchase, how much it cost, and then the running total of the account. And so what we want to do today is take that data, this is just a screenshot, and get a data visualization output where we're going to look at all the transactions that we would call either fast food or groceries, just anything related to food in general, and group it on a per month basis and look at how much that individual spent per month. To start, we're going to start with the packages we need. Okay, so to start off, we want to get the files that we're working with, and that's when I use the glob package. So I'll say CSV files equals glob.glob, and we want to look for anything in our data cleaned directory. This means work from the current directory that the file is in, so main finance analyzer.py, work from that directory, and then go into this folder with the slash, go in that folder, and look for anything that ends in .csv. So we will run this. And now you will see we have our list of files here. But we have a file that we don't want. So these are all the account files, and then we have this file here that I don't want. And this is why we use the glob package, because we can do things like this. You can say account. And then what this says is find any file that starts with account. It can have anything you want after that until it hits the file extension .csv. So we will run this. And now, CSV files, we have all the files that we want to work with. Next step is I want to combine the data frame into just one frame to work with, one data frame. So I can say for file in CSV files, I want temporary data frame, which is going to be load the file at the path, which is data cleaned. Pardon me, CSV files is already giving you the path, so we can just say read the file at that path. There is no header in this particular download from the bank, so we're going to give it column names instead. So we'll say names equals date, description. I'm going to call it an expense, a credit if it's a refund. Actually, let's call it a refund if it's a refund, and total. Because if you don't do this for this kind of file that has no header at the top, then it will assume that the first row is your header. So, I mean, even to be explicit, we'll just say header equals none, although you don't need to put this if you are specifying the column names. And we want a list of smaller data frames to combine, so we'll just say df list equals this. So we've initialized an empty list object, which is a Python specific object, I believe, or to me is Python specific. It is not an array in some ways that you would see in other languages, so just keep that in mind. I'll bring that up later. Okay, so df list append df. Okay, and then at the end, we're going to say our combine df equals this concat function, like concatenating a string, and it wants a list of data frames. And we'll do this list of data frames. It's important to know when you're combining data frames that you have to watch out if the index needs to be reset or not. So I'll just run this. And I want to, in general, just print. Let's just print the first 10 elements of the whatever data frame we come up with. So it's 0 to 10 every column. Combined df. Okay, so this means this is a way to use absolute numbers to refer to your data frame. So just print the first 10 columns, sorry, the first 10 rows, and then print every column. And this is an example where you may think, oh great, I have my proper data frame list, but we can see here, if we start a plot.figure0, we're going to do plot.plot combine df.index.values. We will see that actually the index is increasing. It hits, let's say, 40 something rows, then restarts, and that's because this represents every file. So here, where we're looking at this number here that's incrementing, you may think this increments all the way to the end of the data frame, but actually it restarts in between, and it's good to know to avoid that. So I believe there's an argument here which is ignore index equals true. To go through all this data, and if something is a fast food purchase, we want to label it as fast food. If something is a grocery purchase, we want to label it as groceries. So I'm going to initialize my own list of keywords. You can imagine you could get this from like a web list, some sort of online database. This one just happens to be something I made just based on the data we have. Okay, so we're just going to take that as a constant. And then now we want to start labeling the data frame. And what I want to do is extract the month based on its name as a string. So we want this x-axis here to say April, May, June, July, not have the number. And there's a few ways to do that. So we're going to just go through each row one by one. And then I will show you how to do it as just one line. So we'll just start with combine data frame, go through each row. This function will actually also give you the index. So in general, it's good to know that, I mean, in Python, sometimes let's say you have a list A, -1, -3, and you want to go through it, you have this fact that you can just say for value in list A, print value. So here it actually prints the value, which is a nice feature of Python, but quite often you want to actually also get the index. So a lot of folks will say, I want the index and the value itself, and you add this enumerate function, and you just need to be aware that if you're calling iter rows, it behaves the same way. You get the index, and you also get a series. So the goal now is to create a different column and call it month. And there's a few ways to do that. First, we'll do it in kind of a brute force way, which is month string equals the date string. So you're going to extract the whole thing, and then you could, the easiest way is just say month equals the month string, and just look at the first two characters. That's one way to do it. So here you extracted that. Another way to do it, we should start using our regex. Just in general, when you're trying to extract something from a string, you can say values equals regex find all. You give it a pattern to search for, month string, and I want to search for, I think, this equals search. This is another way to do it. So you have values dot group one. That's, one way to do it. You got the string. I think this is a good example to show how you can use OpenAI and ChatGPT to help you in situations like this. I'm eventually going to use the datetime object instead, but you could say, I have a string, like 08/12/2023. How do I use regex to extract the month, day, and year as numbers, and then also convert the month number to its corresponding string. Okay, it gave us a pretty long example here. Let's just use this part of it. So this is going to say match to this pattern. For us, I'm just making sure it's a forward slash, it's a forward slash. I'm just going to take this helpful little block, put it in, and then what you could do is say combine df dot lock at this index month, make it equal to, there's this calendar package, this is why I'm importing it, dot month name. When you look up the calendar package, you'll see it stores the month as it's just an array. Access it at the month number. This is one way to do it. So here you can see we've extracted the month name. These are all useful things to know, how to match a string pattern. It's a very common exercise. Now there should be a way to do this in just one line. I'm quite sure we can do something like combine df at month. The way we're going to do that is we say combine df date equals pd to date time. We're going to store the date as a datetime object, and then I believe we are able to say call the month column dot dt dot month, and because each value, I may have to add the word value after here, because each value is now a datetime object, this should just give us the month. Step over. Oh, it gave us the month in terms of a number. Right. Okay, we'll stick with this. And so we have the month in terms of a number as one line without all of this. And this will be a good way to learn the mapping function. So now we have a case where we know that this package has the month name in this array if we could just access it at this location. So we'll get rid of all this. I'll keep this as a comment. And what we're going to do now is say this column, we want to map a function to every element of what's already there. And the syntax for this is lambda x, so our variable is x. We want to match simply calling this package dot month name at the variable, which is x. Misspelled calendar. And then we have the month name as a string. This could also be combined to one line, but it's not too bad as it is. And it's explicit, so get the month as a string. Okay, so now we have the month as a string. The next thing we want to do is, for each description, assign it to either a fast food item or a grocery item. And I'm actually going to kind of do a similar thing where I'll show how to do it as a for loop and then contract it to just calling a function. So for example, we would say for, let's say we started with the initial logic that you'd be aware of, which is just go through every row, check if the description is within our keyword list, and then if I find that it matches this, log it as fast food. If I find that it matches a grocery keyword, then log it as groceries. So we'll say for I, the index and the row in combine df dot iterows, we'll say for keyword in fast food keywords. We want to do the same regex matching we were doing before, which we could say is so match equals regex dot search. What am I searching for? I'm searching for literally the keyword in my description. And if I get a match, then I want to say the combined data frame at that location. Type, I'm going to create a new category called type. I'm also just going to initialize it to uncategorized. So if we find a match in fast food keywords, then call this equal to fast food. And if we find a match, we no longer have to keep searching keywords, so we break. It just means we break out of the closest for loop. So if we find a match, call it fast food. Okay, and then we're going to do the same thing for the grocery list. believe this will run. I mean, this could have a case where if something contains both simultaneously, fast food or grocery, it'll overwrite it. But I'm going to ignore that for now because we're going to condense this anyway. So we'll see if this runs. It does not run because I forgot these little brackets here. We'll run it again. Okay, so you can see this got labeled as fast food. And this would be a case where you're saying, oh, I want to know, did it label the grocery tag correctly? So instead of saying just print the first 10 elements, I'm going to print the data frame wherever the combined data frame type equals fast food. And then use the OR operator. Or I'll do it as two separate statements, why not? And then we'll do the grocery data frame. So here you can see, yes, I have a data frame where a bunch of purchases are flagged as fast food and a bunch of Loblaws or other grocery stores are flagged as grocery. This is doing it separately. Be aware you can OR masks, so I can just put this OR statement here, put in this other condition, get rid of that, and then now you can get a data frame that is both conditions masked, which is good to know. Again, that's why this is just a great application case to learn all the basics of what you can do. So we've gotten to this point. So we have flagged it, but it would be good to know that we could actually do this in one line, similar to what we did here. And the way we're going to do it is we're going to create a function because we know what this is trying to do. We'll go create a function. So we'll go up here, create a function at the top of our file, and we'll define this function as find match. And it's going to take an input string, and it's going to take keyword list dictionary and no match name. So this will be what it returns if it can't find a match. And this input, this keyword list dictionary, shows the benefit of dictionaries. So keyword list dictionary equals curly brackets is dictionary notation, and you can say fast food is fast food keywords and grocery is grocery store keywords. And then the idea with this function is we want to use both these elements, return this tag if it finds these keywords, else it's going to return no match. So we're going to initialize it to say return, this is the return value, I'm just going to call it return match name equals no match name. So initialize to no match found, just in case. I also want to return the used keyword. So I'll initialize that to just empty to say that it didn't use anything yet in the match. And we're going to say for key in keyword list dictionary. So for fast food case or the grocery case, we want our list of keywords. So keyword list equals keyword list dictionary at the key we're currently looking at. And then for for keyword in keyword list use our friendly regex again. We're going to look for a match equals regex. We want to search for the keyword in our input string, and if a match is found, then the return match name equals the key that we're looking for, because it's iterating through fast food and then grocery. And the used keyword equals, keyword that we're iterating. And then if we found a match, stop going through the list, break. I mean, this still has the problem where it's going to check both and then overwrite a fast food match with a grocery match if it's a string that has both, but we're just going to not assume we have to make a decision in those cases. And I'm going to first just return the return match name, which is awkward naming, but keep it there. Okay, so we're just going to start with returning just the match name to show how we can turn this into all just one line. So we'll go here and we're going to say the combined df at type equals combined df description, apply a function for every value, lambda, the variable is going to be called x, and we want to apply the function we just made, which is find match. The input to that function is now x, the input string that it's doing the application over. The keyword list dictionary we just made, I believe it's called the same, keyword list dictionary. Yeah, that's just a constant. And we want it to say uncategorized. It says the dictionary object is not callable. Pardon me, that's because this needs to be square brackets. Run. And it's looking good again. It's been tagged as fast food or tagged as groceries. I also wanted to know if we look at our final figure here, we also want to see what keywords were actually found and what keywords were found for groceries. So to do that, we're going to return also the keyword that it used, but now it's returning two things. Oh, okay, right. So you can see in the type, we no longer see fast food or grocery, we see a tuple that has two entries. We want to put those two entries into their own separate columns. So if I put this back to 0, then we get the original output that we wanted, but we want to actually use both outputs. So what we're going to do is say we want to create a new column called type, but another used column called used keyword. And now this means it's going to map to these two columns. So now when we get rid of that 0 argument, and this is just an issue where it wants the output to be a series. So now you can see we've assigned a type and we have a keyword that was used. The next thing we want to do is I also want to extract just all the keywords that were used, the subset of keywords. So used fast food keywords equals unique. We want the unique values of the combined data frame wherever type So we're going to use our Boolean mask again, except we're going to operate on the used keyword column. Used grocery keywords is wherever the data frame that we're working with is a fast food type. We're going to do copy just so that it explicitly won't. There is that difference here because if you set it to this, it will be equal to each other. Like you'll be operating on the subset within this data frame. But if you do copy, then you know you're working with a whole new variable, which doesn't mean much for what we're doing, but it's good to be aware of that. So df1, we now want to take the summation by month. So we say df1 equals df1. We're going to group by month. So group by month. So expense, say fast food series equals df1 expense dot sum. Also, okay, so now we have our fast food series, and we'll do the same for the grocery list. And we also want the months that we're working with, so we might as well just take the index. In this case, the months are the same for both. So month series. Okay, so we have the amount per month, and we have the month where the amount was spent. It's kind of time to get into phase 2, which is to make the bar chart. So we'll start with just a normal bar chart, and then I'll build on it in order to create this final bar chart. So we want to get text boxes in the middle that show the amount, and then have it as a stacked, and then show a line with what the average was, and then a line with what like an expected value could be, or an ideal value. So plot.figure 0, plot.bar, we want month series, and then fast food series. Color, we want it to be blue, and then plot dot, we want to give it a label, which will be month. We want to give it a Y label, which will be dollars. We'll run that, do an initial show, which we can do with plot.show. We get a bar chart, it's a bit blue. So what I did was tone it down with the alpha parameter, call that 0.6. We're going to put a plot.show here so we can see it. Erase this. Whoops. And we'll give it a label equals fast food per month. And we make that label show up by giving it a legend. Now our bar chart looks the following after this loads. Our bar chart looks like this. Now we want those text labels. So the way we're going to do that is say for month in month series. The value that we want to display is going to be the amount of that month, fast food series at I. And we're going to put a text box at that month, at that value, divided by 2. And then the string is going to be just the value itself. So we'll start with this. We will see that we have decimal issues we have to deal with. So we can see that we have all these decimal places we don't want. We want it to be centered. So one of the easiest ways to do that is I'm going to round this first and then convert it into an integer. So I'm going to round it first, so I don't want the integer conversion to lose data. And then have the string value. We also want it to be horizontally lined or vertically lined correctly. So we say vertical alignment equals center, horizontal alignment equals center. Okay. And then we can add the background. So if we search plot.text, how do I give it a background? So I want this light gray and this edge color with an X. How do I give it that? And you add this dictionary here. As for face color, you want light gray. For edge color, you want black. We also want the $sign here. So we're going to do this. So now we have those boxes. We want the second bar chart now to be stacked on top. And so we add the second set of data, the grocery series. We set the bottom equal to the fast food series. This is grocery. Fast food. We'll make it green. We're also going to give it a text per month, the value of which will be, this could be part of it. Okay, so now we have those centered text boxes with the $sign. What else are we missing? We want this little paragraph now to the right, which is just an interesting bit of formatting. So it's a string we're going to define here. String equals, we'll just start with fast food keywords. And then for keyword in used fast food keywords, add to the string one plus keyword plus the new line character. So we'll run that. Make sure it compiles. Okay, so it puts it here, and we want it to the right. And to do that, we have to change the coordinates that this text function is working with. And after some research, you can see that how to do that is you say transform equals plot get current axis. While we're here, we'll make the vertical alignment center. And the point of this is that now you're not working in terms of the data's x and y. You're working in terms of normalized coordinates of the plot. So 1.05 all the way to the end, but a bit to the right is going to be the start. And then halfway, so that's 0.5. And then we run this. And we see now it's to the right. But it's a bit off to the side for one. And it's also cut off. And we want it bold at the top. So we use LaTeX formatting. So we're gonna make it a raw string, bold format. And now that it's a raw string, it won't be able to read this new line character. So you have to end it here and then add the new line character like a normal string. So because we have to add these $signs to say that it's trying to do LaTeX formatting. There, and then we have our fast food keyword list. Okay, and then the way around this is you have to adjust the plot space. So there's a command called subplots adjust. Probably different ways to do this, but we're gonna do it this way. And then while we're here, we're going to add the grocery keywords. So string1 equals string1 plus. And there we go. So we added area on the right with this subplots adjust function, which I got from this ChatGPT. I said how to add more white space to the right of my figure window.